Okay, in this video we're going to be answering our third exam style question looking at the chain rule, which is this video going to look at also logarithmic differentiation. So let's answer the question below. So we need to differentiate the natural log of 4x squared minus 3x minus 5 for 2 marks. And you could see that I've written on the left hand side the chain rule and on the right hand side the differential for the natural log. And first I'm going to use the long method and then use the shorter method, which you'll find is probably much easier than the longer method, to see if I get the same answer in a much shorter, concise way. So let's use the longer method first. So first we're going to say y is basically the question, so we're just going to write it again. So y equals natural log of 4x squared minus 3x minus 5. So that's the first step, which all you'll find is the same first step with the shorter method too. The next part, we're going to introduce our letter u into the equation. So we're going to say let u be this here inside the brackets, 4x squared minus 3x minus 5. So that is 4x squared minus 3x minus 5. I'm going to leave a bit of room and I'm going to say, if we put that back into our equation, we're going to get y equals the natural log of u. So that'll just be the natural log of u. And the reason why I left some space is because we're going to differentiate each of these expressions. So if we do the top one first, so we have du by dx, and that will be 8x, so you bring the 2 down and you times it by 4. So that will be 8x minus 3. And likewise, if we do dy by du, and with natural logarithms, so if you had this scenario here, you just got in general, so you've got natural log of u, so we don't know what u is in this actual expression here. We put 1 on the top, and this u comes in a denominator here, which will be like this, so that'll be 1 over u. And now we can use the chain rule at the top to actually work out what the differential of this is. So I'm going to say dy by dx. I'm just going to write it again actually. So we've got dy by du times du dx. And this is good now because we've worked out each of these already. So we know dy by du, that is 1 over u, times du by dx, which we know is 8x minus 3. So that is 8x minus 3. And what we also know is what this here is, u. We know that u is actually this here, 4x squared minus 3x minus 5. So what we're going to do is put that into our final expression. So we'll have 1 over 4x squared minus 3x minus 5. And the 8x minus 3 is still present here on the end. So we've got 8x minus 3. And we can just tidy this up in a very simple way. So we've got dy by dx. And all we're going to do is bring the 8x minus 3 to the actual numerator. So we've got 8x minus 3. And then we've got 4x squared minus 3x minus 5. So that is the answer, but let's see if we can do this using the shorter method I was mentioning earlier. So as I also said, the first part is exactly the same, so we're just going to write the question again. So we've got y is going to be the natural log of 4x squared minus 3x minus 5. So the next part is extremely important to using this method. So you can see on the top I've written this expression here. I'm going to explain this now, but I'm just going to write it again. So y is f dash x, f of x. So what does that mean in this question? So this here, f of x, well, what that is here is actually this. That's f of x there. And that is what corresponds to f of x in our generic form up here. And so if bearing that in mind, that is f of x, we just do what this formula is telling us to do. So we know f dash x just means the differential, and we know of that would be just 8x minus 3. So that's 8x minus 3, and fx would just be that expression, just nothing done to it. So that's just 4x squared minus 3x minus 5. And you can see just in 2 steps we've actually solved and differentiated the above question. And if I was in the exam, I'd be doing it the shorter way. So you could see that 8x minus 3 over 4x squared minus 3x minus 5. There you go, that's the exact same answer, but you could see we did it in a much shorter time period, and that'll probably work out much better in the exam when you've got the time pressure, and this longer method might lose you crucial marks towards the end of the paper. So that is how you differentiate this question using the chain rule, looking at logarithmic differentiation, and I hope that was helpful.